Okay, one more problem. This is just another practice problem, but the algebra gets a little more interesting, and how this all the substitution gets a little more interesting. So here we go. First things first, we're gonna just find the directions would say find critical points, find your critical points. Okay, key things first here is you need to be able to translate the word critical points. When you see that in the test, when you see that in directions, that means max, min, or saddle. That's it. Now, okay, so if you want to try this problem, pause the problem. You'll have all the skills. Possibly you might get stuck in the algebra, but as far as the calculus goes, you should be ready to rock. All right, now I'm going to do the problem. The partial with respect to x, right? We start with the x direction. So looking at this first term, it has x to the first, so that's just going to result in y squared. Minus the next term, squared comes out to the front, so that's going to make it minus 2x, leave the y alone. Third term, there is no x's, so it's really x to the 0, so the whole thing just becomes 0. All right, there's the first one. Now, the partial with respect to y. Same game. Y squared, so the 2 is going to come out to the front. So that's going to leave us with, 2xy minus, let's see, we have the next term, we have y to the first, so therefore that's just going to become y to the 0, so that's going to leave us with x squared minus 3. Now, solving. Highly, highly, highly recommend. Look for things that factor. Both of these problems look complicated, but if you notice here, both terms in this have a y in them, right? So what I'm going to do is, I'm going to A, set this equal to 0, and 2, I'm going to factor out a y, because then I'll be left with y minus 2x. And now, it makes it just a little more simple. I can break this up and say I know one of my values is going to come where y equals 0, and the other one is where y minus 2x equals 0. And while I can't directly solve that and get something to work with, what I can do is say y equals 2x. So now I have two different things to work from. So let's start from this one. We're going to take this y equals 0 and sub it into the other direction. Because over on this side, I don't see how to factor that. No. So what I'm going to do is say, I'm going to kind of make a note to myself. This is for when y equals 0. I'm going to highlight that in yellow so I don't forget the yellows came from each other. So now, I'm going to say 0 equals, now everywhere I have a y, I'm going to replace it with a 0. So this is going to result in what? That whole thing becomes 0. So it's just negative x squared minus 3. And now I can solve this, right? This we can do. We add 3, divide by negative 1. So what is that going to be? 3 over negative 1 equals x squared. And the square root of that, hey, what do we notice? Square root of negative number is imaginary. So therefore, what can I say? No solutions are going to come from here. So while it does look like I have a min or a max where y equals 0, I just found out it results in no solutions in the other direction. So I can toss that one out. We can toss that out. We're not going to use it. Okay, so then let's do the other one. For the direction where y equals 2x. And let me highlight that. That's coming from right here. So we're going to go over here. All right, so now everywhere I have a y, I'm going to replace it with 2x. So 0 equals 2x times 2x minus x squared minus 3. All right, so therefore 2x times 2x makes 4x squared minus x squared minus 3. So then when I subtract 1 from here, or subtract 4x and negative 4x squared and negative x squared, that's going to result in 3x squared minus 3. So I add 3, divide by 3, so that gives me x squared equals 1. That's awesome, because now the square root, x equals plus or minus the square root of 1, which is just equal to plus or minus 1. That's amazing, because now I know what to pair it up with. Do I pair up this x equals plus or minus 1 with this y equaling 0? No. Or even if you looked over here, no. Where did this plus or minus 1 come from? It came from the fact that y has to equal 2x. So I now know when x equals 1, I take that, sub it into there, I know y would equal 2 times 1, or aka y equals 2. And when x equals negative 1, so that's be y equals 2 times negative 1, so that gives me y equals negative 2. So now I have my x's and y's that get ordered. I know it's 1, 2, comma something. and -1, -2, comma something. So now I have my independent variables. I have my x and my y, so we have to take both of those and use them back at the original equation to figure out my z's. Okay, I will pause the video. I'll be right back. Alrighty, so I substituted in those values, and for my z values, I got -4 and +4. I did it quickly because it doesn't really affect much as far as our answer goes, for at least demoing on how to do the process for you guys. So if I made a mistake, let me know, but I think I did okay. All right, so now let's clean this up a little bit. So now, to figure out what these points are, we need our second derivatives. So we need the second derivative with respect to x, which will come from right here. So let's see, y squared, that doesn't have any x's, that becomes 0, minus, so let's see, this derivative x to the first becomes x to the 0, so that just leaves us with -2y. The second derivative with respect to y, that's going to come from right here. So let's see, that would be what? 2x. There's no y's in that term. There's no y's in that term. So it's just 2x. That's not too bad. Okay, now I need the derivative with respect to x then y, or y then x. That doesn't really matter. So I will do it from, it doesn't matter. I'll just do it from this one. So now the derivative of this with respect to y. So that results in 2y minus 2x. Okay, now I need to take these equations and use them in the second derivative test. So the d of xy, which is equal to the second derivative with respect to xx, times the second derivative with respect to yy, minus the derivative with respect to xy squared. And I need to test it at both of these points. So the first one I'm going to do is the derivative at 1, 2. All right, so in my first equation, everywhere I have an x, I'm going to replace it with 1, and everywhere where I have a y, I'm going to replace it with a 2. So let me just write it this way. So this is -2 times 2. And then the yy would be 2 times 1 minus the derivative with respect to x then y, so this would be 2y. So this would be 2 times 2 minus 2 times 1 squared. All right, and now let's figure out what that equals. This is going to equal -2 times +2, that's -4 times +2, and I can stop right there. Why can I stop right there? Well, I know this -4 times 2 is a negative number. And when I subtract whatever number this is, when I square it, it's going to become positive. So a negative minus a positive is going to equal a negative. So therefore I can immediately say this thing is a saddle point. You can finish out the math if you'd like, but it's going to be negative. It's going to be saddle point. I'm moving on. So I know right here I have a saddle. So I have the point of 1, 2, -4, and it is a saddle point. Okay, let's check the other one. Let's see, this is negative, what was it? -1, -2. -1, -2. And so here we go. The first derivative with respect to xx, it's going to be -2 times -2 times derivative with respect to y. Second derivative with respect to y would be 2 times -1. And immediately, once again, I can stop. I won't, but I'll fill this in here. So this would be 2 times -2 minus 2 times -1 squared. And the reason I can stop is right now I'm just looking at this. I have a positive times a negative, which means my answer is going to be negative. So I have another saddle. So I know the point of -1, -2, +4 is a saddle. All right, so I hope this helped. I hope this gets your feet wet and get started, because there's a lot of algebra you're probably going to need to ask some questions about. All right, good luck.